All right, so here are the solutions to the Chapter 10 review problems. All right, we want to simplify the square root of negative 144 over 49. So first, since this is a square root, we know that it's an even root. And whenever you have a negative under the radical and it's an even root, we can't simplify it. This one is not, sorry, let's do this. This one is not real. All right, number 2, simplify 49 to the 1/2 power. All right, whenever you have a fractional exponent, remember that the denominator is the root and the numerator is the exponent. All right, so I can rewrite this as the square root of 49 to the first power, or just the square root of 49, and that is equal to 7. All right, so 16 to the 5/4 power, that is going to be the fourth root of 16, and then we raise that to the 5th power. The fourth root of 16 is 2, and then 2 to the 5th power is equal to 32. All right, number 4 is 36 over 25, and that is raised to the negative 1/2 power. All right, so first I can rewrite this as 25 over 36, and now it's going to be to the positive 1/2 power. So that means that I will take the square root of both the numerator and the denominator, and so that will equal 5/6. All right, number 5 is a similar example. First, I'm going to flip the fraction to make the exponent positive. So I'll make this 81 over 49. And now it's to the positive 1/2 power. Take the square root of 81, the square root of 49. So this will equal 9/7. All right, number 6, the 5th root of y times the cube root of y. I'm going to rewrite these with fractional exponents, and the reason why I'm doing that is because my roots are not the same. All right, so I'll rewrite this as y to the 1/5 times y to the 1/3, and now I want to give them the same base using the LCD. The LCD is 15. So I'll multiply this fraction by 3 over 3 and this one by 5 over 5. So that'll be y to the 3/15 times y to the 5/15. And we know that we're going to use the product rule. A to the m times a to the n is equal to a to the m plus n. So that'll be y to the 3/15 plus 5/15. We can write it that way. So that'll be y to the 8/15, and I can leave it that way, or you have to pay attention to the instructions on the test. If it says to rewrite it as a radical, then you'll write this as the 15th root of y to the 8th power. All right, number 7, the cube root of y squared over the 4th root of y. All right. So what I want to do is Again, since I don't have the same root, I can write them as fractional exponents. So this will be the same as y to the 2/3 over y to the 1/4. I want to give them the same base. The LCD is 12. So I'm going to multiply this fraction by 4 over 4 and this one by 3 over 3. So now I have y to the 8/12 over y to the 3/12, and I'm going to use the quotient rule. So a to the m over a to the n is equal to a to the m minus n. So this will equal y to the 8/12 minus 3/12 is y to the 5/12. So again, pay attention to the instructions because you may be able to leave it this way, or if you have to rewrite it in radical form, it'll be the 12th root of y to the 5th power. All right, number 8. 64 a cubed b to the negative 9th power, and that is being raised to the 1/3 power. All right, I can rewrite this as the cube root of 64 a cubed over the cube root of b to the 9th. All right, I dropped that b to the 9th to the denominator because I have a negative exponent. All right, now we will simplify this. The cube root of 64 is 4, the cube root of a cubed is a, and the cube root of b to the 9th is b cubed. All right, number 9, we have a to the negative 5/6 over b to the negative 6/5, and this is being raised to the 4th power, and we're multiplying that by a to the negative 1/3, b to the 1/3, and that is to the negative 3rd power. There are several ways we could do this. Let's start by flipping my negative exponents here and making them positive. So that'll be b to the positive 6/5 over a to the positive 5/6, and that is raised to the 4th power. All right, now if I have a power raised to a power, I multiply. So I am here, this portion, I'm using this a to the m to the n is equal to a to the m n. So negative 1/3 times negative 3 over 1 is going to give you a positive a. All right, b to the 1/3 times negative 3 over 1 is going to give you a negative 1. So b to the negative 1st power, I drop it to the denominator, and so this will be a over b. All right, so now I have here a power raised to a power. Again, we're going to multiply. So that'll be b to the 24/5 over a to the 20 over 6. All right, and I'm multiplying this by a over b. All right, so now if I want to get a common denominator for the a's and a common denominator for the b's, the LCD for a is going to be 6. So I can multiply a times 6/6. So a to the 6/6, and this will be b to the 5/5. And then we're going to use the quotient rule, so we will subtract. So I will have b to the 24/5 minus 5/5 over a to the 26 minus 6. And remember, the largest exponent determines where it will go. So that's why the b is in the numerator and the a is in the denominator. All right, so now all we have to do is simplify that. And that'll be b to the 19/5 over a to the 14/6, which I will need to reduce. So the final answer is b to the 19/5 over a to the 7/3. And again, you can leave your answer this way unless the instructions say to rewrite it in radical form.